25. Also known as the final theory, this theory reconciles the quantum field theory and the theory of general relativity to link and fully explain all known physical phenomena and predict outcomes of every experiment conducted according to principle. However, the issue of how to fully combine the two huge theories of general relativity and quantum mechanics still stands. 24. Another interpretation of the world brought about by quantum mechanics is the idea that this three-dimensional universe is just a hologram. According to reports from a German-British observatory, small ripples have been allegedly detected in space-time that might be proof for quantum pixelization. 23. As technology advances, the need for precision arises as well. Inaccuracy of different objects such as clocks and thermometers could be attributed to the phenomenon of quantum noise. This noise impedes the ability of objects to possess perfect measurements. Thus, by eliminating this noise, things like atomic clocks or quantum thermometers gain perfect accuracy. 22. The laser is an invention made possible by quantum mechanics and was once thought to have no practical use. However, innovation and development have enabled these emissions of specific quantities of quanta to be applied to different inventions, ranging from CD players to missile-destroying defense systems. 21. According to scientists, nothing can be truly random with the help of quantum mechanics. If they had enough information about a dice roll, they could simulate a dice roll and come up with a prediction of the outcome in advance. However, by creating quantum noise and measuring the levels of noise produced, they are able to develop truly random numbers that could be used for data encryption. 20. One of the earliest interpretations of quantum mechanics, the Copenhagen interpretation, assumes that during the act of measurement, particles change their behavior accordingly. According to this interpretation, particles exist in different states, but they are only forced to assume one state when an observation is made. This may be weird, but it is indeed supported by mathematics' wave function collapse. 19. Not only did quantum mechanics create tangible scientific breakthroughs, the concept of multiverse, or the existence of all possible realities, it is also the product of different interpretations of quantum physics. Proof of this can be traced to orbiting observatories that follow remnants of the Big Bang and different mathematical models, which argue a cyclical universe. 18. Birthed by quantum mechanics, the string theory also conceived a greater scientific possibility, or impossibility: multiple dimensions. According to researchers, the universe consists of at least 11 dimensions. These multiple dimensions apparently are not only possibilities, but also necessities for the string theory to function. 17. Holodynamics is the application of holographics, quantum physics, and developmental psychology to allegedly understand the potentials of self and life. It views reality as a dynamic holographic information system that is intimately connected with human consciousness on both a macro and micro scale, manifesting a quantum potential field with every particle of the human body. 16. Based on the quantum field theory and general relativity theory predictions, a black hole is a region of space-time from which gravity prevents anything, including light, from escaping. The hole is black because it's able to absorb all light in and around it. There is actually a mathematically defined surface that indicates the point of no return. Scary fact, there is a general assumption that massive black holes do exist in the center of most galaxies. 15. Superconductivity is a quantum mechanical phenomenon where there is exactly zero electrical resistance and expulsion of magnetic fields when cooled below a certain temperature. Superconducting magnets are very powerful electromagnets that are used in MRI machines and mass spectrometers. In the future, they could also bring forth high-performance power transmission, power storage, and magnetic refrigeration. 14. There is a model in quantum mechanics called the particle-in-a-box model, which describes how a particle could move freely in a small area bound by impenetrable barriers. This model was applied and developed to create the field of optoelectronics, which is the study of electronic devices that detect and control light. Some of the fields that were created through the quantum mechanical effects of light on electronic materials are phototransistors, laser diodes, and optical fiber communications. 13. Physicists have discovered a Joule-like geometric object within quantum physics that drastically simplifies calculations of particle interactions and challenges the notion that space and time are fundamental components of reality. 12. Trekkies rejoice! It's no longer science fiction. Matter can be dissolved into particles, transported, and reassembled at another location. So far, this has been possible with data transfer and other large molecules, but as for the possibility of being used on humans, I wouldn't hold my breath. It is indeed possible to scan every molecule in the human body and reassemble it in another area, but according to quantum physics, This changes the entire object. You can't make an exact copy. 11. The phenomenon of entanglement tackles the quantum interconnection of particles, such as atoms separated in physical space. Scientists found out that entanglement could be responsible for the ability of plants to turn 95% of the light they absorb into energy during photosynthesis. Examining this phenomenon could possibly give birth to solar cells derived from nature. 10. Scientists have recently discovered tiny semiconductor crystals that could very soon create a breakthrough in the field of medicine. These quantum dots supposedly grow when exposed to ultraviolet radiation. As such, they could be used to latch on to cancer cells in order to pinpoint the cells that should be exterminated. 9. Quantum mechanics also gave birth to existentialist problems. The Higgs boson, or, as it is more popularly known, the God particle, is what is believed to give mass to some of the most fundamental particles like electrons and gluons. By finding and isolating the Higgs boson, scientists might be able to understand how matter could be balanced with antimatter and what really happened to the universe after the Big Bang. 8. To prevent aggressive threats and genius hackers from prying, quantum cryptography has emerged from developments to encode data inside individual particles of light or photons. Cryptography deals with a key comprised of ones and zeros that enables the program to reveal a hacker presence right at the moment he uses the key to pry the message open. 7. Quantum computers are one of the fields of application of quantum mechanics, which could revolutionize the state of technology of computing machines. Compared to digital computers, which encode data in binary digits, quantum computers use quantum properties to store data and perform operations, which would allow computations and algorithms to run much faster than regular ones. 6. Quantum tunneling originated from quantum mechanical application, where a particle could tunnel through a barrier it normally could not penetrate. Quantum tunneling is important in the operation of numerous devices like the light switch, flash memory chips, and USB drives. 5. Some large-scale systems also exhibit the effects of quantum mechanics, like the phenomenon of superfluidity. It is the state of matter in which it acts like a fluid with zero viscosity, enabling it to self-propel and travel defying the force of gravity. Superfluidity's most basic applications in today's science are dilution refrigerators and spectroscopy. 4. Spintronics is the new technology recently developed at the Massachusetts Institute of Technology, which uses electrons in their spinning state to store and transfer information effectively. This is different from today's electronics, as it uses the electron's spin direction instead of its charged state. This could lead to faster, energy-efficient, multifunctional devices that would trump today's gadgets. 3. Brazilian scientists have started working on creating quantum turbulence in an extremely cold atom gas-filled chamber within a laboratory. The study of turbulence in a controlled environment could eventually lead to scientists being able to control it in nature, thus possibly solving the dilemma of unstable airplane rides. 2. Under quantum mechanics, an item can be broken into subatomic particles, enabling it to be transferred from one location to another in under a second. This phenomenon could devise a way to store bank account information, protect it from possible threats, and transfer them at a rate that is seemingly impossible. 1. Studies on quantum mechanics launched experiments regarding the possibility to travel from our world into an alternate world in time. During an experiment in 2010, scientists were able to pinpoint how an isolated piece of metal could move and stand still at the same time. This is because of the ability of quantum particles to move backward and forward through the time continuum, an ability that may lead to possible time traveling in the near future. Let's just hope they have it ready by October 21st, 2015.
If you like what you just saw, consider pressing that orange subscribe button on the upper right hand corner of your screen. And if you want more awesome lists, check out our 25 most dangerous hikes, treks, and climbs on Earth, and our 25 interesting beer facts that will leave you tipsy.